In today's lecture, we are going to discuss a very important concept in Python programming, which is object-oriented programming, or we commonly call it OOPS. Now, if you have been following the previous lecture till now, which we have covered most of the programs, uh, we have been mostly been writing program in a straightforward way. We create variable, we use conditional statements or loops, we create functions and we pass values using functions and execute our program accordingly. And for smaller programs, this approach is absolutely perfect. But the question is, what happens when our program becomes really large? For example, suppose we want to develop student management system or maybe a banking application or even something which is much larger like an e-commerce platform. In these kinds of applications, we are dealing with hundreds of or thousands of data of different pieces of data. And if we simply keep adding variables and functions without organizing them, our code will be very extremely to handle. So this is where we get introduced to OOPS, that is object-oriented programming. OOPS gives us the way to organize a program around the real world. We will start with classes, objects, then understand constructors, self-keyword, etc. etc. After that, we will discuss important concepts like encapsulation, inheritance, and polymorphism. And throughout this lecture, we are going to understand OOPS from very basic. So don't worry if you have never studied about this topic. We will understand everything very like from basics. So let's get started. So first, let's understand why do we need it. Imagine that we have a student or library management system. Okay, let's take student management system. For one student, we might have their name, roll number, marks, or subject they are studying, and all and all. For one student, managing these values isn't very difficult, or maybe for five, it is not that much difficult. But now imagine that we have thousands of students. We need to manage the same kind of information for every single student. So think of like now library management system. We have books, we have who issued them, who returned them, we have fine and etc. and many entities. Or a hospital management system. We have patients, doctors, appointments, medicines, etc. Banking application, and many more. Even applications that we use for our day-to-day life follow similar concept. For example, Instagram. It has users, post, comment, and message. Like e-card website like Amazon has customers, sellers, products, orders. So large application contain different entities that have their own information and behavior. OOPS helps us to represent these entities inside a program. Instead of creating one huge program where everything is mixing together, we divide our program into meaningful components. Okay. Now, to understand how actually OOPS work, we need to know two fundamental terms. That is class and object. Since for that first, let's cover this topic again. Since I told you, object-oriented programming is a way in which we organize our program mainly using two terms, classes and objects. The easiest way to understand this is suppose you have want to manufacture a car. Okay. Before manufacturing actual car, we create a blueprint of it. That blueprint specifies what color should it contain, which it may have a model, or for example, a car may have a brand, model, color, speed. And apart from these information, a car also performs certain actions. Okay, these are the properties of it, and some actions that are a car can start, stop, accelerate, and it can apply brakes. Now, the important thing is that the blueprint itself is not the actual car. The blueprints simply defines how car should be or how it should be created. In programming, we think that blueprint is as a class, and actual car that is created is the object. For example, suppose our class name is car. Okay. From this class, I could create one object that represent a red Tesla. I could create another object containing white Hyundai. And I could create another that represent black Ferrari or something. All three objects follow the structure defined by the car class. But each object can contain different information. Okay. So a class is a blueprint, and object is the actual object or actual value or actual instance that is created using these blueprint. Okay. I hope with these example I think you could understand this little bit easier. And if you are still not understanding, don't worry. As we will cover this whole lecture, you will be able to know what we are going through. Then we now again let's study in details what is actually class. Okay. Now let's convert the idea of our car one into an actual Python code. Okay. So for that, what we have to do, we are going to open up Visual Studio Code. So today we are going to create a class. So for creating a class, we use a keyword that is known as class. It's a keyword, okay? Now then we name whatever the class name should be, semicolon, very important. And I'm writing inside that class. The class is, as I told you, is a Python keyword. Student is the name of the class. It tells Python that we are defining a new class, and student is the name of our class. Then we have pass. Pass simply means that currently we don't want to write anything inside the class. Python accepts the class, but the class doesn't have any functionality yet. It didn't have made it like functional right now. We just simply meant that we don't want to write anything inside it, so we created something like this. Okay, that's why we used pass here. Now here's something important. Creating this class does not mean that we have created an actual student. Think of our previous example, for example. Creating the blueprint of a car does not mean that we have physically created a car or a physical car automatically exists. Similarly, the student class is only the defining of a structure. If we want actual data, we need to create an object. So for that, how you are going to write? I was seeing the PPT. To create an object, then you have to do like this. S1 equals to student and this braces. Now S1 is our object which we also can say as instance. Remember this. These are the terms. They might look very complicated, but you have to remember them like that. It would be easier for you for learning the advanced topic like more clearly and precisely. Okay. So here S1 is an object of the student class. Okay. S1 is a object. I could create similar kind of data object again by S2 equals to student, and that is right. Now remember what we wrote here. It is the class name. It is the class name with the parenthesis. Now, uh, now suppose we have two separate student objects. Both objects belong to the same class, but eventually they can store completely different data. Like S1 and S2 can have different data. S1 might represent one student, S2 could have another student. And the one of the biggest advantage of classes, we define the structure once and then create as many as object we need to create. But right now our object does not contain a name, roll number or mark something. So how do we provide initial information when an object is created? For that we use constructor. Now constructor is used to initialize an object. Okay, is used to initialize an object when we create it. In Python, you usually or commonly see the written word that is init. So what we do is, since we already created a class, then def def two underscores in it, again two underscores, self name. Now this init is the constructor what I was telling you about. It is to initialize an object when we create it. What do I mean by that? I'll let you know. First let me write something. Self.name equals to name. Yeah. Now don't worry about self right now. We are going to understand it properly on the next slide. For now, focus on init. Okay. Suppose I created an object like this. Right now I'm writing here like S1 equals to student, whatever we have wrote here, student. And inside that I wrote Isha. As soon as the Python creates this object, the init, that is the constructor, it is a method, like init method is all called automatically whenever after we write this code, init method is called automatically. So the value of Isha goes to the name parameter. Here goes to the name parameter. Now I don't have to actually call it manually. It is automatically called. The value Isha is going to in the name parameter. Then this line self.name equals to name. It stores the value inside that object. That means whatever the object we had, this value would be stored with this. Now if you write like this, print s1.name. So Isha is printed. You can make the student class more useful. Instead of storing only a name, we can store like multiple things. Like if you can store a roll number, then marks, and what we are going to do, we are going to write self dot roll self dot marks marks. Okay. Then instead of Isha, I'm going to write 101 and 88. Suppose. Since I just called here S1 name, so only a name has been displayed. Okay. But and we are going to create another thing. Let's make another object. This is an object. Remember, it's 1, 2, 78. Simple. Okay. Both S1 and S2 are created from exactly the same student class. But look at the data. It is totally different. S1 has roll number, one name, roll number and marks. S2 has different values. If I write S1 dot name and if I write S2 dot name, so the constructor makes object creation much more convenient. Every time we create an object, Python knows what initial information is required and stores it in the correct object. Now the question must be, how does Python know whether name belongs to S1 or S2? So that's where now we are going to learn what we will start talking about self. So the self is also keyword. Okay, self is a keyword. The self is something that you will constantly see while working with Python. Self refers to the current object. Suppose I told you that okay, we have created two objects S1 and S2. we are working with S1, self refer to S1. When we are working with S1, self refers to S1. That means this self refers to S1. When we are working to S2, that self would again automatically will be working for S2. That means it self is going to work on the current object. If I want to work on S1, this will self would work for S1. If I want to work on S2, self would go to S2 and work on S2. The Python allows to keep the information of different objects separate. Okay, so you that's why we let's add another method like okay. Right now I have created a constructor here. I am creating something def display self and I want to change the self dot name. Okay. Yes. Yeah. I'm just going to give it range s1 dot display. Now, so okay, we have already created the print. So we like because we have already created a function that have a print. So I'm just going to do it like that. Okay, semicolon is missing. So this is the error. Yeah. Name Isha. Python understands self refers to the S1. I was talking about the S1. Therefore, self.name means that name stored inside the S1 object. If I do it for roll number or marks, it would automatically goes to the roll number and the marks stored inside the S1. But if I write it like S2.display, that means the same method now works with information stored inside the S2. That's the beauty of this approach. We don't need to create a separate display function for this. We write the method once and we can every object can use it again and again. So whenever the self feels confusing, just mentally replace it to the particular object. Simply, the idea will help you to understand most of the use of self. Okay, encapsulation. This is one of the most important principle of OOP. The word sounds technical, but the idea behind it is quite simple. Encapsulation means keeping related data that and the method that works together with the data. Okay. Encapsulation means keeping related data and the method that work with the data together inside a class. Okay, that might be very like confusing. Simple. Suppose understand this using a bank account. Yeah, bank account. Let's create a different thing. Class bank. Okay. Def. I'm creating a constructor. So balance, balance, and self dot balance equals to balance. Yeah. Our account has a balance. Okay. But in proper application, we don't want random parts of our program changing the balance however they want. For example, we don't want someone simply deciding, okay, let's make my balance 1 lakh rupees randomly. Instead, we want controlled operations. Okay. So, for example, if I create something called deposit, I will say that okay, for deposit, amount should be greater than 0. Now, if someone wants to add money to the account, they use the deposit method. Okay. Okay. If inside of this, I create another deposit self amount. If amount is 0, then self dot balance is equals to amount. Now, if someone wants to add money to the account, they use the deposit method. Similarly, we can create, we want to see the balance. For that, we have def get balance self return self dot balance. Uh, balance because I have used balance everywhere. So, so let's say our initial bank balance is 5,000 rupees. So I created an object that bank have 5,000 rupees. That means that it is going to initialize that okay, the balance is 5,000. Simple. No issues? Good. Then we will do one thing. We will call account. From this, I want to use the deposit method and I want to deposit 1,000 rupees inside it. Okay? Since parameter is amount, I have entered a numerical. Now let's see. Okay. Now, when we will check the balance, we will get 6,000. Later, we could improve this method even further. For example, if someone tries to deposit a negative amount, we can reject it. For withdrawal, we can check whether the account has enough balance or not. The bigger picture is the class should only control how internal data is used. Next major topic is that was encapsulation, like protecting your data. Simply, if I want to say, it just protects your data. Encapsulation just makes sure that every related data is stored inside the same class. Like it is more cleaner. It hides the internal detail and exposes only the things that are essential. Hiding the essential data or the internal details is for the protection purpose is encapsulation. The inheritance. Inheritance is allow us to reuse the existing code. Suppose we created a class animal and we created def, breed, self, something, something. Then now we want to create a class dog. We created a dog name class. A dog is an animal. So logically, a dog should already have the basic behavior of an animal, right? Instead of writing the same code again, since dog is also a part of animal, instead of writing the same code again, we inherit from animal. What did I do? Instead of I just made a parenthesis and wrote the parent of class inside it. Okay. Here animal is the parent class and dog is the child class. What do I mean by that? That whatever the properties animal would have, dog automatically will adapt them, inherits them. Like we have a hierarchy inheritance, it is going to work like that. Now let's create d1 equals to, like we are creating an object that d1 equals to dog, the class name. We initialized it. I can write d1 dot bark and get dog is barking. For example, I want to print this message that dog is barking. But something more interesting is that I can also write d1 equals to breathe, because since breathe is the like breathe is never defined inside the dog class, but still we can use it. Big why? Because dog is inherited from animal. This is our parent. So whatever properties it have, class dog would have the same properties. Okay, students and like so instead of defining name and age, instead of defining breed and bark separately in animal and dog, we can keep common information inside the same thing. Okay, So inheritance helps us to avoid repeating the same code. We can reuse it. Polymorphism. It means basically poly means many and morphism here means forms. So polymorphism is basically many forms. In programming, it means that same method or interface can behave differently depending upon whatever we have. For example, we have your class equals to birds. So if you want, we can create a class named crow again. We can create a class called sparrow. Now, for example, both crow and sparrow can have same method like sound because they both have sound, but the behavior would be different. A crow is going to have a different sound, a sparrow would have a different sound. Like crow say cow cow, sparrow chirps. Same method name, but different behavior. That's polymorphism. Instead of we can have overriding. This is a simple example of method overriding. The parent already contains a sound name here. See, sound method we already have in the parent block, that is the bird. Now for crow and class sparrow, we can use same sound method. But the child classes provide their own versions. Sound would be there, but like sound would be there, but crows will have a different sound rather than sparrows. So it is so this becomes very extremely useful when we are building a larger applications. Okay. So I think we covered so far so thing. Now let's quickly revise everything we covered. We started with OOPS. We learned about classes. Classes like a blueprint that defines what an object should contain. And then we learned objects. Objects are actual instances. Then we learned about self. Then we discussed about init method that allows us to initialize data of an object when object is created. Self means this particular object. After that, we learned encapsulation, which helps us to keep the related data together so that internal information is accessed or modified by a specific person and protection is maintained. Then inheritance that allows child to reuse the properties of a parent class. And then we learned polymorphism that allows same method name to work totally different for different classes. Okay, now your homework is to start with making an employee class, store the employee ID, salary, something, and after that you have to make a mobile class, and you can even modify changes in your status problem. I don't have a problem. So try to do these. Okay. So this is a mini student management system live coding. It is simply you have to create it. I am just going to give you an idea. So first, what we are going to do, this is a blueprint I have created. First, we are going to create a class that is student. Now we need to decide what information a student should contain. For example, name, roll number, marks, and all. So objects should be created accordingly. So you have a constructor inside this class and initialize name, roll number, marks, names, objects inside it. Now every student object must have three values. Okay. So for that you have to create another method. Like you have to create another method. Now if like our class has both data and behavior. The data is like name, roll number, and marks, and the behavior is that it is going to be displayed. Okay. Then you have to create two objects or three objects, whatever you want, and simply display all the details. Okay. So you have to do this. I hope you can do all this. Uh, so since we had a good journey, And with that, we have completed our Python programming course. That today we have started everything from very basic of why hoops and what is hoops. We created small programs within small examples. The best way to understand OOPS is by actually creating classes and objects by itself. So make sure you try your practices. And I want to make you a suggestion that programming language is about practice. Whatever the theory part was should be done by me. I have created them. Now it's your task to practice until unless you understand the logic behind the programs. Once you understand the logic, you are going to be very fluent in this any kind of programming language, not only Python. So whatever the theory was there, I have covered it. We have built something very strongly from my end. I hope you do understand what I was trying to make you. Thank you for watching. Keep practicing, keep coding, and I'll see you soon. Thank you.